Okay, guys, so next page in your notes is lesson 4.4. It is labeled graphs of sine and cosine. So we are starting off today with just looking at the graphs of sine and cosine. Okay? And what you will see up here on the screen, or on the top of your notes, is what the basic graph of sine and cosine look like. Okay, now, here's the deal. Sine and cosine do not just end right here. Sine and cosine go on infinitely in both directions. And so, as we look at this graph of sine x, okay, now, first of all, if you graph these on a calculator, anytime you graph a trig function on a calculator, your calculator must be in radians. Trig functions just automatically work in radians on the calculator. So if you try and graph this on your calculator in degrees, the graph will look different and it won't be right. Okay, so the calculator would have to be in radians to graph it. Now, with that said, you guys are like, oh, I can just graph this and write down the graph? No, you could use it as a check to an extent, but the details I'm looking for are not going to be, I'm not going to be able to get those from just copying down your graphing calculator graph. Okay?
Can I please go and grab my calculator? I forget it in my local.
I honestly don't really think you'll need it today.
Okay.
Okay? As weird as that sounds, we're graphing, but this is the graphing by hand. Okay? Okay. And I'll show you what it looks like on the calculator, just so you can see.
Yep.
But, so as we look at y equals sine x, some things to point out, okay? So it starts at 0, 0. It goes up and has a maximum above pi over 2. And notice how high does it go? It goes to a high of 1. Comes back down, goes through 1 pi, has a 0 at 1 pi, right? Then it continues down, has a minimum at 3 pi over 2. And notice that minimum is at negative 1. And then it goes back up and cuts through 2 pi. What you are looking at right here is a cycle of sine x. Okay? Now, you keep going after that is the idea. And so, if I show you, okay, sine x, let's see, I'm in radians, and I'm going to do a trig screen. Okay, I went to Z trig because it works a little bit better. But notice, here's what my calculator says sine x is. That's not just one up, one mountain, and one valley, right? It keeps going on forever and ever and ever. Always going to heights of 1 and lows of negative 1. Every 2 pi is going to be the same. Okay, so from 2 pi to 4 pi is going to look like what 0 to 2 pi looks like. So on and so forth. Okay? Okay, yep, yeah. And that is true. If you guys recall back to, we did do sine x and cosine x as part of our 12 functions in the fall, yes? Lesson 1.3, those 12 functions, this was here. We're just going into more depth. Yeah. Now, cosine x. Cosine x, in a way, looks totally different. However, it's essentially sine x, just taken and shifted left, right, it's shifted pi over 2 over, is what it is. Okay, so notice cosine x, if we're just looking at one cycle of it, starts at a high of 1, 0, 1. It cuts through pi over 2, so has a 0 at pi over 2, a minimum under pi, which is at negative 1, cuts through 3 pi over 2, and a maximum at 2 pi. Now, if I graph cosine x on the same screen, notice the blue was sine x, the red is cosine x. It's the same graph, just shifted left pi over 2. Okay? But when we draw just one cycle of cosine, sine looked like a mountain and a valley, right? When we draw just one cycle of cosine, it looks like a big old valley. Okay, so now needless to say, we're not just graphing sine x and cosine x, because otherwise I'd say, okay, graph these, we're done, let's move on. We have to look at, okay, our graphs aren't necessarily just sine x and cosine x. They have different transformations with them. And so we have a chart here that has some information. A, if there is a number or value out front multiplied by the function. Do you remember from your Algebra 2 days what that does? Okay, we called it a stretch or a shrink in Algebra 2, or maybe stretch or compression, right? Either or. Okay, so that A value is a stretch or a shrink. So instead of always going up 1 and negative 1, maybe it's going to go up and down farther. Maybe it's going to go up and down less. Now, in terms of sine and cosine, we call it our amplitude. Notice it's how far above and below the center line to count. Okay, so it is equivalent, though, from your Algebra 2 days, of thinking of it as a vertical stretch or shrink, or compression if you would prefer that wording. So I wrote off to the side, vertical stretch / shrink. Okay. 2 pi over b is what we would call the period. Now, I talked about one cycle, right? The graphs you're looking at there are one cycle of each. So a cycle of sine or a cycle of cosine is 2 pi. Now, if there is a b value, notice where is b? B is the coefficient on x. If there's a b value that's a coefficient of x, that will affect the length of the cycle. So maybe you'll have a cycle longer than 2 pi. Maybe you'll have a cycle less than 2 pi. Okay? If we are adjusting the cycle, instead of vertical stretch, shrink, this is our horizontal stretch, shrink. Okay? And again, I'm going to explain to you, help you figure out how to use all of this. And this chart will be what will be really helpful to getting you through. Okay. C divided by B. Okay. C divided by B is what we call a phase shift. That means sine, and maybe instead of starting at 0, 0, maybe it scoots left or right some. Okay. This is a phase shift, and if it's scooting left or right, this is equivalent to saying horizontal translation. Notice C divided by B is taking what's in the parentheses, right? And so if you remember what's added or subtracted in the parentheses to find your horizontal shift, that's what we have here. So C divided by B is horizontal. I'll use the official word and say translation. Notice there's a plus D at the end. From at your Algebra 2 days, what does a number added or subtracted at the end of the equation do? Moves it up or down. Okay? Now, so what we call it here is it's the center line. This is what you'll label your x-axis. So instead of moving our graph up and down, we're just going to label our center line as something other than 0 possibly. Okay? But this is essentially equivalent to whatever your vertical translation would be. And lastly, we have the one type of transformation we haven't talked about is a reflection. When do reflections happen? When there's a negative out front. And so when there is a negative out front, so notice when it says a negative A. So earlier the amplitude was the absolute value of A, so just whatever the A value is. If A is negative, that means there is a reflection, and we will reflect it across the x-axis, or in other words, flip it upside down. Okay. So those are all the details. when we go through to graph these, I'm always going to take you through a process to the point when it comes to the quiz and a review worksheet. I'll kind of have it set up for you to fill in all the blanks that I want to see answers to. Okay, so using this chart here, let's try example 1. Y equals 3 sine x minus 4. So identify the pieces here. Let's start with center line. What's our center line going to be? Negative 4, because the center line is the D value, and it's the number added or subtracted at the end. So I'm going to write here that center line is negative 4. And as I said, come quiz time, I'll have blanks. I'll expect you to fill in what the center line is. Next thing I want to ask after center line, amplitude. What kind of amplitude do I have?